Today's daily LeetCode problem of the day is find the kth bit in the nth binary string, number 1545. This problem is a bit of a brain twister and involves recursion and binary string manipulation, but I'll break it down for you and walk you through step by step. So let's get started. Here's what the problem is asking. You're given two numbers, n and k, and your job is to find the kth bit in the nth binary string. So what is an nth binary string? So we have string of n, and it's going to be denoted as string of n index, where string of the index is minus the first index, so the index that comes before it, plus we're going to add a 1 bit, and then we're going to reverse and invert the bits of the previous index. And we're going to do that as long as I is greater than 1. So our job is to find the kth bit in the nth binary string. So the kth bit is going to be, let's say, the third bit in the second string. And for each binary string, it's going to be built in a specific way. So we're going to start with just a 0. In our first string, we're going to start with just a 0. Then we are going to first add the original string, which is 0. We're then going to add a 1 to the middle of that string. And then we're going to add our string again. So this is the same as this, but we're going to invert the bits. So whatever was a 0 is now a 1, and whatever was a 1 is now a 0. And then we're going to reverse it and go ahead and put it at the end here. So as we can see, for S of 2, we have 0, 0, 0, 1, 1. So that 0, 1, 1 is going to be right here, 0, 1, 1. And then we add a 1, and then we reverse and invert all the bits. So instead of 0, 1, 1, we now have 0, 0, 1. So this 0 turns into this 1 turns into this 0, and this 1 turns into this 0. And we basically just want to do that an n amount of times. And once we find our nth string, we're going to look at the kth bit in that string and return that bit. So when k is equal to 1 and n is equal to 3, so here's our third possible string. Our first bit is going to be a 0. For n is equal to 4, so we're going to look for our fourth string, which is the same as this one. And we're going to look at our 11th bit. It's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is our 11th bit. So we're going to do that to find our nth string with our kth bit. So to solve this problem, a key insight would be to use recursion to avoid using or having an extremely large string. So we're looking for the kth bit in the nth binary string. So instead of building the full string, we can use recursion to simulate the process for us. So for our recursive approach, we can use these key observations. The midpoint of S of n is always going to be at position 2 to the nth power minus 1 divided by 2 plus 1. That's just because of how the string is built. It's going to keep doubling plus 1 in size, so that's how we can always find the middle point. So if k is our midpoint, the answer is always going to be a 1 because we always add a 1 to our midpoint. If k is on the left side of our midpoint, it behaves like the same position in S of n minus 1 because this string is the exact same as this string. Then if k is on the right side, it behaves like a mirrored inverted version of the previous string. So if we're on the right side of our midpoint, it's the same exact string as before, but reversed and inverted. So let's dive into the coding. For our public find kth bit, we're simply going to return a recursive function, which is going to be our helper function. We will pass it our n and our k value. Then we can have a private character helper function, which is going to receive integer n and integer k. So this recursive function is going to have a base case to see if our n value is equal to 1, because if it is equal to 1, if n is equal to 1, our first possible string is just 0. So we're going to return 0. Otherwise, we're going to find our midpoint, and if our answer is the midpoint, then it is a 1. If our k is less than a midpoint, we can subtract the string that we're looking at and only look at the previous string, because our kth bit is going to be in that string. Or we are going to look at the right half of the string. So first, let's find our mid value. So integer mid is going to be equal to 1, and we're going to use a bit mask for this. So we're going to shift it to the left of n minus 1. So this is basically going to find our string of 2 to the power of n minus 1. Then we can check if k is our midpoint. So if k is equal to our midpoint, we will return a 1. As we know, the midpoint always has to be 1. Otherwise, if our k value is less than our midpoint, we could look at our previous string. So we can return our helper function and pass it n minus 1, nk. And our last case is if it's to the right, we invert and mirror it, and then we can recursively look for it. So we're going to have our char mirrored is going to be equal to our helper function, and we're going to pass it n minus 1 and our midpoint minus our k minus our midpoint. So that's going to effectively invert and reverse our string, and after that we can simply return our mirrored bit, which is going to be equal to 0. If it is, we will return a 1, because the inverse of 0 is 1. Otherwise, we will return a 0. So that's it. That is our recursive function. We're first checking if n finally reduces back to 1, then that means our string is just 0, so the answer is 0. We then find our midpoint by creating a bit mask, and it's just going to simply take n and shift it to the left 1 bit, which effectively doubles it. And using the double, we can find the half, because it's 2 to the power of n minus 1. Then we can check if our k is our midpoint, it's always going to be 1. If our k is less than our midpoint, we are going to look at the string previous to the one that we're currently on. And if our string is to the right, or bit is to the right of our midpoint, we are going to look at the previous string again, but we're going to reverse it and invert it. So if we run this, it passes our test cases, and if we solve it, that passes all solutions. Thank you, and follow for more daily LeetCode solutions.